Skeletal muscle power is an important feature of performance in so-called explosive sports like weightlifting and sprinting. But other sports also require moments of explosive power, like kicking a ball, the serve in tennis, or shot put or javelin. Power produced during exercise depends on the type of exercise performed. For example, a long-distance cyclist may produce only 50 watts per revolution during a long cycling race. A strength athlete, on the other hand, may produce more than 6,000 watts during the most explosive part of a clean and jerk. In this video, you will have a closer look at some of the key aspects of muscle power. Muscle power is the ability of muscles to produce force in or at a given time. Nowadays, it is well known that to everyone in sports that muscle power is as important, if not more so, than strength alone. The ability to produce force as fast as possible is what makes the elite athlete in many sports today. The size of the muscles, so their cross-sectional area, but also the ability to fully activate the muscles in a coordinated manner determines power performance. Running out of energy is generally not an issue in explosive sports. The available stores of energy-rich phosphates, so ATP and phosphocreatine, are large enough to support a few seconds of skeletal muscle contraction. If exercise is somewhat longer, so up to 15 seconds, phosphocreatine stores can become limited and this will reduce power output. With longer sprints or multiple moments of explosive power in a limited time, also the anaerobic metabolism will contribute to energy. In these situations, accumulation of lactate will limit performance. At the cellular level in the muscle, type 2 muscle fibers play a key role in muscle power. This in contrast to type 1 fibers that are of crucial importance for muscle endurance. Let's have a closer look at type 2 fibers. Type 2 muscle fibers are very good at short and powerful muscle contractions. The reason why type 2 muscle fibers are able to contract so powerful is due to a number of so-called electrochemical properties. First, type 2 muscle fibers are able to spread very quickly the signal from the nerve cell that controls muscle fibers to contract. So they are fast contracting, so-called fast-twitch muscle fibers. Secondly, type 2 muscle fibers have myosin ATPase, which works very quickly. Myosin ATPase is the enzyme that breaks down ATP into ADP and phosphate to create energy. This energy can be utilized very fast in type 2 fibers. Third, type 2 muscle fibers have large intramuscular ATP and PCR stores and increased activity of glycolytic enzymes, making them well suited to intermittent high-intensity exercise of short duration. But although type 2 muscle fibers have a great power, they are more susceptible to fatigue and are less capable of dealing with acidification, for example from lactate. So type 2 muscle fibers can on average generate strength 3 to 5 times as fast as the oxidative type 1 muscle fibers. However, as said before, they fatigue easily, meaning that power output will drop. This brings us to the next part of this video. Proteins provide a structural base for tissues and organs, also skeletal muscle tissue. Actin and myosin, for example, are crucial for muscle tissues to contract. And specific enzymes, such as myosin ATPase, determine the physiological function of muscle tissue. Proteins are synthesized and degraded continuously. Exercise and nutrition are the two major regulators of protein synthesis and breakdown, and hence key factors in regulating skeletal muscle mass and function. Contraction and amino acids both stimulate the molecule with the beautiful name mTOR. mTOR is the heart of the protein synthesis machinery. It's a signal that stimulates synthesis of new proteins. The amino acid leucine is in particular good at activating mTOR, explaining its popularity as a supplement. So regular training in combination with proper protein ingestion will support skeletal muscle mass and function. but you probably already knew that. In this video, you have learned that power, so the production of force in a given time, is an important aspect of performance for so-called explosive sports. Muscle mass, but also its coordinated contraction, determines power performance. Type 2 fibers play a key role in muscle power due to its specific characteristics. Both exercise and dietary protein are important regulators of skeletal muscle mass and function.